In this video, we're continuing topic 5.4 about relative extrema and the first derivative test. So we are going to start with this left-hand column just to define what extrema is. Extrema is the plural for a max or a min. Oops, I'm not spelling that right. For max or min, and it's kind of in general. We call them extrema if we're talking about them both in general. Another name for relative extrema would be local extrema. So that word local and relative are interchangeable. So we are looking at the relative extrema, or it says let g prime of x equal 3x squared plus 4x plus times x minus 5. Find the intervals where g is increasing or decreasing and find the location of any relative extrema. How nice is this? Look at what they did for us. They already took the derivative, so we can kind of skip step one. We're just going to set it equal to 0 and start finding our critical numbers. So my critical numbers would be 3x squared equals 0, x plus 4 equals 0, and x minus 5 equals 0. So I'm seeing divide by 3 square root it would be 0. X equals negative 4 and x equals 5. So this means that I'm going to get out my sign chart for this. So I've got my intervals from negative infinity. I drew that fence way too close, didn't I? Let's try that again. Negative infinity to negative 4, negative 4 to 0, and 0 to 5, and then 5 to infinity. I'm going to pick my x values. I'm going to talk about my derivative. We're going to talk about my original. Okay, so let's start picking some values. So I know that this is my most simplified form of the derivative, so I'm going to plug in there. So the x values that I'm going to pick, let's look like negative 10, maybe negative 1, 1, and then 10. I know that this term here, no matter what I do when I square it, is going to be positive. So this is always, always, always a plus. Okay, so let's start taking a look at these. I put in a negative 10, so that's going to make it negative and negative. So positive times negative is negative times negative is positive. Looking at negative 1. So negative 1 into here would be positive, and in here would be negative. So we'd have positive times positive is positive times negative is negative. Looking at this one here, we're putting in a positive 1, which would make this middle term positive, and this would still stay negative. So we'd have positive times positive is positive times a negative would be negative. And then finally, we are putting in a 10. So we'd have a positive here and a positive here. So positive times positive times positive is positive. Anytime we are positive, we know we are increasing. Anytime we are negative, we know we are decreasing. So intervals where g is increasing or decreasing, and find the location of any relative extrema. Okay, so we know that. Let's start with our increasing, decreasing. F is increasing on negative infinity to negative 4 and 5 to infinity because f prime is greater than 0 on these intervals. Okay, f is decreasing on negative 4 to 0 and 0 to 5 because f prime is less than 0 on these intervals. Or you could say negative. Okay, and then I have to look at maxes and mins. So we know we're increasing to decreasing. It's decreasing to decreasing, so there's no relative extrema there. And then decreasing to increasing. So this one is a max, and this one is a min. And it said to identify any of them. So we would have to say f has a relative max at x equals negative 4 because f prime changes from, and look at what it's changing from positive to negative there, or at this value. And then we have f has a relative min at x equals 5, because, and again, I just look at my chart, f prime changes from negative to positive there.